Hey, good morning, everybody. This is Mr. Ainsworth. We're going to get into part two and finish the lesson on rates of change and polar functions here in lesson 8.5 at AP Pre-Calc. Okay, well, let's get on it. Number 5, consider the polar function r equals -2 plus 4 cosine theta. Remember, r in function notation, f of theta is the same as r. It's just a function in respect to theta, where theta is your angle, your input, and your radius is your output. Okay, so we're going to substitute these angles in and get our radius value. So let's get started. Here we go. All right, when you substitute 0 in, cosine of 0 is 1 times 4 is 4 minus 2 is 2. Okay, so r is 2. Whoa, that's a little technology glitch right there. Okay, so 2. At pi thirds here, 60 degrees, cosine 60 degrees is half. All right, half of 4 is 2, plus -2 is 0. Okay, so at this point, let me see, pi halves. Pi halves, cosine of pi halves is 0 times 4 is 0, plus -2 is -2. Just keep on rolling. Cosine of 2/3 pi, okay, it's negative in quadrant 2, so -1/2 times 4, -2, plus another -2 gives you -4. Okay. Okay. And then what else? What else? Pi, cosine of pi is -1. That's how you maximize this function right here. -1 times 4 is -4, plus -2 is -6. All right, there's your max right there. And then 4/3 pi, that's quadrant 3, cosine still negative. And so it's going to be -1/2 of 4 is -2, plus another -2, -4 again. And then 3/2 pi down at the bottom of the unit circle, cosine 0 there, times 4 is 0, plus -2 is -2. At 5/3 pi, quadrant 4, you get that's 1/2, okay? Cosine of 5/3 pi is 1/2 times 4 is 2, plus -2 is 0. So you're back at the pole. So there, you're at the pole here when the radius is equal to 0, okay? And you're at the pole here. So this right here, this is a limestone with the inner loop. We'll talk about that in a minute. And you're at the pole. It goes through the pole. And at 2 pi, cosine of 2 pi is 1 times 4 is 4, plus -2 is 2. So you're going to get 2 here. So you got to be really good at evaluating. All right, you substitute theta in. This is your input variable, and you get your radius, which is called your output or your range. Okay, so let's go ahead and graph this function in rectangular form and polar form. Rectangular form, this right here, is y is equal to -2 plus 4 cosine of x. So notice that we have an x and y axes up here. So might as well just graph that right now. We got a midline. So this is your k value or information on the midline. 4 represents your amplitude, okay, above and below the midline. So what you want to do is you want to draw your midline first. This is how we did it back in previous sections. So you get your midline at y equals -2, and then you go up 4, down 4, because the amplitude is 4, which means you're going to have to go up here at 2. These are the guiding lines. The function, the wave function, is going to bounce and oscillate in between a 2 and -6, because we've got to go down 4 as well. Okay, so amplitude gives us that information. So amplitude is 4, so you go up 4, down 4, given the amplitude of 4. And then you remember basics on cosine function, which starts at a max. And so at 0, you get 2, so it starts up here. Just look at the table, 0. Okay, and then at the pi halves it hits its midline, and then at pi it hits its minimum. Okay, so I think I said max earlier, I meant minimum. That's its lowest value right there, and then back to the midline again, and then up at 2 pi. So then you just sketch your function like you normally do. This is a cosine function, so it oscillates up and down, all right, from max to min, max to min. So it's up here. We have a max at 2. We have a minimum of -6 here. So I already know a couple of the answers that it's going to be asked right here. And then you got to graph this in polar form too, right? Right. Okay, so what does this guy look like? And what we did back when we were graphing things is that in polar form, r is equal to negative, or excuse me, a plus b cosine theta. And for these limesons right here, you had to figure out which type you have. Okay, and so what we did is we took the absolute value of a to b. In this case, it's 2 divided by 4, and then we analyzed it. So 2/4, that's 1/2, that's less than 1. So this is a limeson with an inner loop. Okay, and then you want to evaluate it, and we already did. Okay, so all I have to do is plot the points from above. Okay, so you want to take these points and you want to plot them. All right, plot points, because I usually evaluate things for you or with you guys in class. All right, but we already did that, so all we have to do is plot them, and we know the x and y intercepts. Okay, so here we go. So remember, each point is in r comma theta, so that's your polar form. So be very careful here. It's not 0 comma 2. This is 2 comma 0. Okay, it's always r comma theta, the radius and then the polar angle. And if we plot 2 comma 0, that's going to be right here on the second concentric circle at 2. And you just plot a bunch of these points, pi comma negative 6 comma pi, negative 6 comma pi, where's that? Well, 6 comma pi is over here on the left, but then you reflect it, now it's on the right. So it's over here. Okay, so this is negative 6 comma pi over here. And then you keep on plotting like, let me see, negative 2 comma pi halves would be up here. So negative 2 comma, oh no, it'd be down here. Negative 2 comma pi halves would be down here. And then 3 halves comma negative, or negative 2 comma 3 halves pi. Guess where that's up here. I know, counterintuitive, right? But it is. Okay, so remember when r is negative, it's a reflection. So negative 2 comma 3 halves pi is up here. It goes to the pole twice. All right, and then you just sketch your limeson. So here we go. One with an inner loop. Let's see if I can do this. No. Let's try it again. Okay, you got to put the sound effects in. No. Okay, wow, that's pretty decent. Here's your limeson with the inner loop length too. Okay, and notice it has polar axis symmetry because of the cosine function. So polar axis symmetry. I'm just going over some basics that we talked about in the prior lessons. Okay, so now that we have that done, let's take a look at the graph here, the rectangular graph. So from 0 to pi right here, from 0 to pi, I notice that it's decreasing. Oh, you know what? Let me stop. Got to dig a little deeper here. And you know what? Pi, it should have went through pi thirds on the x-axis. So let me draw this curve again here. Okay, I'll explain why here in a minute. It should go right through here because at pi thirds, when theta's pi thirds, r is 0, so it should go through here. There we go. And at 3 halves pi, no, excuse me, 5/3 pi, we get 0, so it should go right through here and hit the axis. Okay, because that's where it changes from positive to negative. So you're going to need to know that. Okay, so be careful there. So we have some very special angles that we need to take a look at. So at pi thirds, at pi, and 5 pi thirds. So I'm going to highlight those. Okay, so because it changes sign at that angle. So this angle, pi thirds, pi, and 5 pi thirds, I'm going to highlight them in the table as well, because this is where the function changes sign, and that's important. I'm talking about from positive to negative. So let's answer some questions here. So on what intervals is theta? What intervals of theta? So on what intervals is f increasing? Okay, so from pi to 2 pi. Okay, so just look at the graph here. From pi to 2 pi, the function's going up all the way. It keeps on increasing. Okay, so this is where it's increasing. And guess what? From 0 to pi, okay, it keeps going down, right? It keeps going down, and so it's decreasing here. So here, decreasing from 0 to pi. All right, increasing from pi to 2 pi. And then what are the min and max? Well, just look at the graph, okay? So max is 2, minimum -6. But if you didn't want to look at the graph and you wanted to calculate them, this is what you would do. Okay, so you would substitute 0 in, because cosine is 0. Cosine function reaches a max at 0, at theta equals 0. So cosine reaches a max, okay, when theta is equal to 0. And then we evaluated that already. Okay, when theta is 0, you get 2. All right, so there's your max, and cosine reaches a minimum at pi. Okay, so cosine reaches a minimum, okay, when theta is equal to pi. We evaluated that earlier too, so we have -6. Okay, and then it asks you, is the function changing faster from 0 to pi or from pi thirds to 2 pi thirds? And justify your answer. So on this one here, we need to get the AROC going. We need the average rate of change. Okay, so here we go. So changing faster, we're talking AROC. Okay, so we haven't done this in a while. It's our first time with polar functions. So let's take a look at our first interval here from 0 to pi. All right, and let's calculate AROC. Average rate of change to see which one's changing faster. So in this case, we got to figure out delta R divided by delta theta. To do that, we got to take f of our first angle, so we'll call that, our second one. So theta 2 minus f of theta 1, okay, where this is theta 1 and this is theta 2 on your interval, just left and right bounds, that's all it is. All right, divided by theta 2 minus theta 1. So what am I saying? I'm saying we got to take f of pi minus f of 0, divide that by pi minus 0. Now we don't have to do any further evaluation because we already did it. So if you look at the table up here, all right, f of pi is -6. Okay, so we have -6. F of 0 is 2, divided by pi gives you -8 over pi. Okay. Okay, now let's work on the other interval. So the other interval is from pi thirds, that's your theta 1, and your to 2 pi thirds, there's your theta 2. Again, theta 1 and theta 2 are just angles, guys. First one and second one. All right, you can even put it here and call it theta 1 and theta 2. Theta 1, theta 2. First and second angle. All right, so what do we get? Let's do the AROC. Here we go. One of the biggest themes in AP Pre-Calc this year. Okay, we've seen it all the way since Unit 1. Okay, so why stop? Why stop at Unit 7? Let's do rate of change in every single lesson. All right, here we go. So the f of theta 1, so f of 2/3 pi minus f of pi thirds, okay, divided by 2/3 pi minus 1/3 pi. What do we get? Well, we look at the table, right? Because we already evaluated the function at all these points. Okay, so f of 2/3 pi, what is that? -4. Okay, f of pi thirds, that's at the pole, so you get 0. Okay, and then 2/3 minus 1/3 is 1/3. Basic math. Okay, and you get -4 divided by pi thirds. And of course, you multiply by the reciprocal, so you get -4 times 3 over pi, which gives you -12 over pi. All right, now which one's changing faster, underline faster? To do that, you compare their magnitudes. Okay, so compare magnitudes, okay? And when I say magnitudes, I'm talking about the absolute value. So you take the absolute value of both of them and compare. So you take the absolute value of any negative, you're going to get a positive. And so notice I draw an arrow and not an equal sign here. So you take the absolute value of -12 over pi, you get 12 over pi. So the question is, which fraction is bigger? And it's this one here. If you have a bigger bigger numerator, you have a bigger fraction, assuming that the denominators are the same, which they are. Okay, so I can say, make a conclusion here. So we have a faster A rock, okay, faster average rate of change, so faster A rock on the second interval from pi thirds to 2 pi thirds, okay, because 12 over pi, okay, 12 over pi is greater than 8 over pi, that's why, okay, and there's your reason. So you gotta, in this class here, you gotta justify everything, and you pretty much have to write everything in a sentence so you can explain your thoughts well. So just keep that in mind. You got to get good at that if you're going to do well on your AP exam coming up here in a few weeks. Okay, or in about a month. All right, on the interval from pi halves to 2/3 pi, is the distance between f theta and the origin increasing or decreasing? Well, guess what? So let's take a look at our table here. So I'm going to take a look at this section here. Wait a minute, no, excuse me. From pi halves to 2/3 pi. Yeah, take this, I'm going to bring it down here. Okay, so I'm just going to recreate the table. So pi halves, okay, this is theta and this is r, and 2 pi thirds, what did we get? So we got -2 and -4. Okay, so -2, -4. So check it out. Okay, so I notice right here that from -2 to -4, it's decreasing. So it's decreasing, okay, and they're both negative. So it's decreasing and negative, and from the lesson, what did we learn? Okay, let's go back in time to the previous lesson. If it's decreasing and negative, which is in the first condition here, okay, it's in the first one here, the distance is increasing. Okay, so if the signs are the same, the distance is increasing, which means you're going away from the pole. You could even see it in the graph. If you take a look here in the intervals between, what did I just say, pi halves to 2/3 pi, pi halves to 2/3 pi, okay, pi halves to 2/3 pi, it's decreasing and it's negative because it's below the axis. So it's decreasing and negative. So you got to be going further away from the pole. All right, so let's state that. Okay, so it's the distance now. Distance from pole. All right, when I say pole, I'm talking about the origin. All right, is increasing. Okay, and again, a little note here, you can also see this on the graph. You can see this on the graph. So just understand that too. Okay, and there we go. That's how it's done. This last page is just a summary page. All right, I'm Mr. Aynesworth here. This is your last portion of the lesson here in 8.5 in AP Pre-Calc here at Great Oak High School in Temecula, California. Hopefully this helped you out. All right, and I'll see you in my next video or hopefully in school. You guys take care. Bye-bye.